So in this problem, we're asked to find the first four non-zero terms of the Maclaurin series expansion for f of x equal to sine x squared. So what we can do for that one is to begin by looking at our Maclaurin series expansion for sine. So that one will be the sum n equals 0 up to infinity of minus 1 to the n. Since sine is odd, all of our denominators are odd. And so we have 2n plus 1 factorial, and then x to the 2n plus 1. And then just as a reminder for that, remember that this series is valid on the entire real number line from minus infinity to infinity. Now, if we want to do a value for sine x squared, we simply do a substitution. So this will be our sum, n equals 0 up to infinity, minus 1 to the n, all over 2n plus 1 factorial, substituting x squared in for x to the 2n plus 1 power. So this will give us a series n equals 0 up to infinity, minus 1 to the n, over 2n plus 1 factorial, x to the 4n plus 2 power. So if we want to write out the terms of this series, what we have when n is equal to 0, we have 1 over 1 factorial, x to the second, minus 1 over 3 factorial, x to the sixth, then plus 1 over 5 factorial, x to the 10th, and then minus 1 over 7 factorial, x to the 14th, and so on and so on and so on. So the first four non-zero terms of our expansion are then x squared minus 1/6 x to the 6th plus 1 over 120 x to the 10th minus 1 over 5040 x to the 14th plus higher order terms. And so we have the power series expansion for the sine of x squared. I hope you've enjoyed this, and I will see you guys in the next example.